Welcome to this APH Access Academy, Multiplication to Perfection. And I am going to hand it over to Dr. Leanne Grillot.
Hello, everyone. I am so glad you are here with us today. We are going to talk about that wonderful magical abacus today for multiplication. Quote on the screen from Pythagoras, numbers rule the universe. They sure do. Let's see what we can get done today. As said, yes, I am Dr. Leanne Grillot. I am the Senior Director of Outreach Services for the American Printing House for the Blind. This is a love tool for me. I absolutely love the abacus. I love the exposure to math that it gives our students, but it is a tool that can be used by anyone with or without sight. And that is the wonderful beauty of the abacus. It wasn't built actually for our population, and yet we have found a way that it works well for us. Our learning objectives for today. We are here for 2 hours. Learning objectives: explain vocabulary, the rules for positioning subproducts, and the purposes of how a multiplication problem is set on an abacus. We're going to evaluate multiplication expressions for their purpose of teaching one digit in the multiplier and any number of digits in the multiplicand. Evaluate multiplication expressions to teach multiplication with complementary numbers in subproducts. Evaluate multiplication expressions to teach any number of digits in the multiplier and multiplicand. And explain common errors students make when multiplying with an abacus. Lots to cover. I will say that if you took the course in the Hive, A Million Manipulatives in Your Pocket, which taught addition and subtraction with the abacus using complementary numbers, you will feel very comfortable rolling in to multiplication. If you haven't, don't worry, we're still going to walk you through it. Some of the movements might feel a little uncomfortable, and I can tell you, go back and practice addition and subtraction. That's how you know you're ready for multiplication. This means your students need prerequisite skills too. Your students need to be able to do addition and subtraction with multiple digits using complementary numbers before introducing multiplication on the abacus. They need to understand multiplication and division are inverse operations. And they have to have an understanding and memorization, really, of multiplication and division within 100. Yes, you could use the cheat sheet 9x9s chart to do this, but for speed and fluency, they should have an understanding of those. Now, why do I talk about what they need to know? Well, let's talk about the standards. Now, these are the Common Core state standards. Your state will possibly have different standards, but think of this as a way to look for them inside of those standards. Math Standards Critical Area talks about in 3rd grade that a student needs to develop the understanding of multiplication and division strategies for multiplication and division within 100. This might be using equal-sized groups or arrays or area models. They should be able to understand the relationship between the two and be able to multiply and divide within that 100. Remember what I said? We need them to actually have that. So in 3rd grade, they might not have that yet, which means you might only be using your abacus in 3rd grade for repeated addition, for understanding a little bit more about multiplication. Depending on the numbers and the context, 4th grade students should be able to select and accurately apply appropriate methods to calculate products, both on paper or calculate them mentally. They should develop fluency with efficient procedures for multiplying whole numbers and explain and understand why these procedures work based on their property values or place values and properties of operation, and then be able to use them. When we get to the 4th grade standards, our students should be solving multi-step word problems that are both multiplication or division, and they should be able to multiply a 4-digit by a 1-digit whole number and a 2-digit by a 2-digit whole number. So we can see that fourth grade might be the time that you formally introduce the abacus for multiplication. Again, you could do it earlier if your student really has a great understanding of their 9x9 times tables. For multiplication, we need to discuss vocabulary that's used, the placement of these problems on the abacus, and then the process by which we solve. Let's talk about our multiplication vocabulary. Most people remember that the result of a multiplication problem is a product. I bet you do. Think about it. Yeah, I knew it was a product, but you might not remember what the other things are called inside a multiplication problem. With regard to the multiplicand and the multiplier, first and foremost, let me say it really doesn't matter which comes first, but using logic and reasoning, we could see why the multiplicand comes first and the multiplier comes second. The multiplicand times the multiplier equals the product. In simple terms, the multiplicand is the thing being multiplied. The multiplier is the number of times the thing gets multiplied. You can't multiply before you have a thing to multiply. So first, what are you multiplying? You will usually see multiplicand and multiplier written in that order and not the other way around. Syntax is in fact important. Let's use an example. I have 5 boys. They have 3 marbles each. If we put the number in the order I spoke, 5 times 3 and equals 15, might sound simple, but is it really correct? Well, no, because your answer would be 15 boys, not 15 marbles. The thing being multiplied is marbles. 3 marbles 5 times. You get 15 marbles, not 15 boys. Marbles are the multiplicand. The boys are the multiplier. The product is the marbles. It's math. Now, there are different symbols for multiplication. The multiplication X is known as the times sign, but it could also be called the dimension sign, the cross multiplication sign, or the vector multiplication sign. The multiplication dot is also known as the dot operator symbol or the scalar multiplication sign. And then the multiplication star is known as an asterisk or star. Now in 4th grade, your student will most likely be familiar with the first symbol, the times symbol. They will be presented with both horizontal and vertical or spatially arranged multiplication problems. As with addition and subtraction, we will be using horizontal problems. These are easier to read in Braille, easier to track in enlarged print. Our students need to already be able to recite their multiplication tables up to 9 times 9 because the abacus is for multiplication of numbers with more digits. This is why I mentioned the math standards for 3rd and 4th grade. While the abacus can be used quickly for repeated addition and some understanding, that full act of multiplication on the abacus will not be learned until the student has learned their times tables. Occurs in 3rd grade, but the student is often more proficient in 4th. As you will soon experience, multiplication on the abacus is a combination of mental math and the use of the abacus for computation. So if you're rusty on your 9x9s times tables, you might want to practice it and then listen to this later. Let's start just as a group identifying the parts. I'm going to look at the very first problem on the screen. It is 8 times 7 equals 56. Which number is the multiplicand in that problem? 8 times 7 equals 56. If you said 8, you got it. 8 is the multiplicand. And 8 times 7 equals 56. Which is the multiplier? Great, you got the 7. And last but not least, which number is the product? 8 times 7 equals 56. All of you are fairly familiar with multiplication. You've seen this over and over again. The words might be new, but your brain has already processed this. But for your student, you might want to just spend some time on identifying the parts of a multiplication problem, because I'm going to be saying these words frequently. It can be very helpful in understanding where you're putting numbers on your abacus by using these words. Okay. Now that the part names are established, you want to make sure that you then start talking about the placement, and that makes it easier. The placement of multiplication is different than addition and subtraction because we actually take the whole problem and set it up on the abacus. So they won't have to go back and check the paper after the problem is set. Okay, we have set the entire problem up, no longer have to refer to paper. So as they read the problem, the multiplicand is set on the extreme left of the abacus. This means it is not set in its value columns. It's not set to the units, tens, or hundreds column. It's set on the extreme left side. The multiplier is set toward the right side, and again, not in its value columns. The product, however, the answer, is set in the proper place value, and that's important. We want to be able to read our answer correctly. So let's talk a little bit about where your multiplier will be set on your abacus. We need to make sure that the placement isn't going to interfere with the product, which will be in those correct columns. So we are also going to use it to figure out the placement of the subproducts or the pieces if it's a very long multiplication problem. So right now, I want you to think of the largest 2-digit times 1-digit product could be. What is the largest 2-digit times 1-digit problem you could think of? Type it in the chat if you can think of one. The largest one possible, 2-digit times 1-digit. Judith got it. Yep, I see. 99 times 9. You got it. 99 times 9. That's the largest one we can think of. Okay. What's the answer of 99 times 9? Ooh, Amy got it. 891. 891 is the answer. So the largest answer for the largest problem we could think of is a 3-digit number. So we know that 3 columns can't be used because our answer could have a number in that hundreds column. Okay? We're going to make sure it's not interfering with the product at all. Out of curiosity, what's the largest 1-digit times 1-digit number? 9 times 9. So how big could the product be? How many digits? It's 81, 2 digits. Again, this thought process might help you understand and might help your students understand where we're going to place it. Let's set a problem. But before we set it, I need one more thing to talk about. There's something called a partial product. This is when we're going to multiple digits. But I need your help in understanding that with just the simplest math. And I talked about this previously in addition and subtraction if they were practicing their multiplication or multiples of a number. When multiplying a number, think in terms of a 2-digit answer, a 2-digit product. For example, 2 times 8, we might say 16. But think in your head as 1, 6, because you're going to set the 1 and then you're going to set the 6. Think of it in 2 digits. This will be important because we are not always adding to the rods that are the same value as the number that is added. You might be adding a 10, that 1 of 16, in the hundreds column. So we want to make sure that they're just thinking about the digits. If it is a problem like 2 times 3, don't say 6, but think or say 0, 6. All products have to have 2 digits. Can you think of a simple 1 digit times 1 digit problem that would give us a product that you would need to put a 0 in front of? Write it in the chat. What's one problem that you could see immediately that you need to put a 0 in front? Okay, I'm seeing people got it. Again, you've got to think about and encourage that thought process. Okay, now we're going to get to setting problems. We're going to start with a 1 digit times a 1 digit number, even though a student will not need the abacus to solve it. They already should know the answer. This is to help understand setting a problem on the abacus and then understanding where answers are, where the product shows up. We need to set the problem. 4 times 2 equals 8. We're going to set the multiplicand 4 in the extreme left column. And then to determine the position of the multiplier, with our right hand, we're going to move from right to left, repeating the problem. And as a beginner student, you might want to say the problem out loud. Repeat the problem where your index finger is touching each rod moving to the left for each digit, as well as the word times. When the finger touches that last verbally spoken number of the multiplier, that is where you begin setting the multiplier's highest digit. I'm going to demonstrate this. Let's set 4 times 2. And the furthest left-hand side, we're setting the multiplicand. On the left-hand side, push 4 beads up. It's right along that edge column. I take my right finger and I roll to the units column and I state the problem 4 times 2. With each movement, I am moving my finger to the bar. I'm trying not to touch the beads, but actually touch the bar that's visible, or you can touch the plastic separation bar. I say 4 times 2. Where my finger stops, I set the multiplier. So I push 2 beads up. My 2 beads are pushed up on the hundreds column. I have now set the problem 4 times 2. Let's set the problem 2 times 46 equals 91. We're going to set the multiplicand 2 in the extreme left column. To determine the position of the multiplier, 46, with the right hand, you're going to move right to left, repeating the problem, while the right index finger touches a rod for each digit and then the word times. When the finger touches the last number of the multiplier that you were saying, which should be the 6 of 46, that's where one sets the multiplier or begins to set the multiplier if there's more than one digit. So that's where you set the 4 because it's the highest digit of the multiplier. Let's demonstrate this one. Let's set 2 times 46. On the left-hand side, I'm setting 2. I'm going to say the problem out loud by moving my finger from the right to the left. 2 times 46. Where my finger stops, I set the 40, move to the right, and set the 6. So the 4 is set in the 4th column, and the 6 is set in the 3rd column. or the thousands and the hundreds. There are problems on the screen. These are ones worth practicing setting multipliers as you get used to these wordings, saying the problems out loud. Remember that a zero or zeros occurring at the end of a multiplier or multiplicand may be difficult for some students to set. Re-emphasize a column is touched to represent the setting or clearing of a zero so that the idea of zero is reinforced. However, if a student still has trouble remembering the zeros, you might want to suggest that the multiplier or the multiplicand with a zero occurring at the end, write it down in Braille for them to remember if they're using a verbal problem as opposed to a written problem. Let's practice just setting a few of these together, okay? The first problem we're going to set is 243 times 6. 243 times 6. The first number, the multiplicand, gets set on the left. I'm going to set a 2, and then a 4, and then a 3. I'm going to say the problem as I move my right hand over. 2, 4, 3 times 6. Where my finger stops, I set the 6. It's set in the 5th column. I'm going to clear my abacus. Let's try 12 times 7. The 12 gets set on the left-hand side. 1, 2. You try to set the 7. Say the problem and set the 7. What rod did you set it on? Type it in the chat. 12 times 7. Okay, I'm going to do it. Let's see if you got it right. 1, 2 times 7. Where my finger is, I set the 7. The 4th column or the thousands column. Clear your abacus. Let's try 150 times 2. On the left-hand side, we set 150. 1, 5. I tap to say I've set that 0. What column is the 2 set on? Well, let's find out. 1, 5, 0 times 2. Each time I said a word, I touched a column. Where I stopped, I pushed the 2 up. It should be on the 5th column or the 10,000ths column. Clear your abacus. I'm going to hop over and let's try 30 times 68. Set the 30. We're going to set the 68. 3, 0 times 6, 8. Where my finger stops, I set the 60, and then I set the 8. You should have it set on the 5th and 4th column. Okay, let's see what you held onto. The very first poll asks you, true or false, when multiplying on an abacus, all partial products have 2 digits. True or false? And then multiply 5 times 7. The multiplicand 37 is set on 5 times 37. The multiplicand 37 is set on which columns? I've seen the poll slide down, so I'm going to end the poll. I share the results. Let's talk about it. Okay. When multiplying on an abacus, all partial products have 2 digits. This is true. All of them have 2 digits. You're going to have to substitute one in there, but you need to have your students listing all partial products having 2 digits. Even if the answer is the product is 6, it should be 0, 6. We need to help them think about that. When multiplying 5 times 37, the multiplicand is set on columns 4 and 3. You have to tap each time. So you're tapping a 5, and then the word times is the next bar, and then a 3 for the next bar, and a 7 for the 4th bar. Where you stop, which is the 4th bar, you set the 3 of 37, and move to the right and set the 7. Okay, let's start to multiply. You ready? We're going to start with a problem that you already know the answer to, just like we're going to start with our students, answers they already know. We're teaching them now how to set where their product is. So 5 times 3 equals 15. Set the multiplier and multiplicand. I'll give you a moment to do that. With your right forefinger, you're going to leave your right forefinger on the 3 and then move it to the right to wait. The left forefinger checks the 5 of the multiplicand, and in your brain you think 3 times 5 is 15. We're going to set the 1 of that 15 in the column to the right of the multiplier, which is where our right forefinger is waiting. And then set the 5 in the next column to the right because we've moved our right forefinger over. Then we're going to clear the multiplier and clear the multiplicand, and we'll get our answer. Let's try this one together. I am going to set 5 times 3. I set the 5 in the far left-hand column. I speak the problem to find out where to set the multiplier. 5 times 3. I set the 3 in the 3rd column over. I read the problem by starting with my right finger and read 3. I hold that number in my working memory. I'm holding 3. I'm going to multiply things times 3. My right finger slides over and waits on the tens column. 3 times what? My left finger goes and feels the 5. So it's 3 times 5. 3 times 5 is 15, but I say 1, 5. Where my right finger waits, I set a 1. I move my finger to the right and set the 5 of 15. I go back and clear the multiplier. I clear the multiplicand, and I read my answer, 15. Let's try another one. Let's try 2 times 3. We know 2 times 3 equals 6, but hopefully you already said 0, 6 to yourself. Set the multiplier and multiplicand. With your right forefinger on the 3, then move it to the right. The left finger checks the 2. You think 3 times 2 is 0, 6. You're going to set the 0 where your finger is waiting. Kind of tap it. Move your right forefinger to the right and set the 6. Go back and clear the 3, clear the 2, read your answer. Let's do this one together. We're going to do 2 times 6. 2 times 6. Set the 2 on the left-hand side. Say the problem. 2 times 3. Set the 3. My right finger rests on the 3. I say 3 and I move it to the right. 3 times what? My left finger says 2. 3 times 2 is 0, 6. Wherever my finger is gets a 0. Move to the right and set 6. Clear the 3, the multiplier. Clear the 2, the multiplicand. Read my answer for 6. Start simply. Start with problems that your student should already know the answer to, practicing placing the product. So these are the simple 1-digit times 1-digit numbers. Make sure that you're putting a mix of products that will have a 0 added to it, those partial products that we were practicing a minute ago. So for instance, the 3 times 1 or 3 times 3, so that our student has to practice placing a 0 in their answer. Okay. Remember we said the abacus is not going to be used for 1-digit times 1-digit numbers because all of those needed to be known. You just needed to know 3 times 5 was 15. You couldn't solve that without doing multiple addition. Now we're ready to move on to 1-digit multiplicand and 2 or more digit multiplier. Now, these problems look a little different. Most of your students are going to see problems that would reverse and put the largest number first. As they learn multiplication, they realize it doesn't matter which number goes in which place. And that's something that you want to emphasize with them, that they have the ability to move the problem to the way that is most comfortable for them. On the abacus, some of the easier problems to solve are when the largest digit is the multiplier. So what we're going to do is we're going to set 8 times 37. I've already given you the answer. Practice for a moment, set the 8 times the 37. Get that in place. Check to see where it's going to be. 8 times 37. What column did you have the 3 on of the 37? You should have it on the 4th column. What number is going to go into your working memory? The working memory, now with 2 digits in that location, gets the first digit in the working memory. What we're going to do is our right forefinger is going to touch the first digit it comes to. It's rolling inward from the right-hand side, and the first digit it comes to is that 7. So the 7 is going to go into that working memory. Our left hand then reads the first number on the left-hand side, which is an 8. So it'll be 7 times 8. Where our finger is resting, our right hand finger is resting, you'll set the 5, you'll move to the right, and you'll set the 6. Since we're done with the 7 of the multiplier, you're going to clear it with the right forefinger on the 3, because that's the next part of the multiplier. We'll read it and we'll put 3 in our working memory. We'll slide it to the right. Our left finger checks that 8, so we say 3 times 8 is 24 or 24. Right where our finger is waiting, we set the 2, and then we move it to the right and we set the 4. We'll clear the 3, we'll clear the 8, and we'll read our answer. Let's look at that problem. Okay, the problem is 8 times 37. 8 is on the left-hand column. 8 times 37, 4 columns over, set the 3, set the 7. My right finger reads 7, puts it in my working memory, and my finger goes right next to it. 7 times what? My left finger reads 8. 7 times 8 is 56. Where my finger is, I set the 50, move to the right and set the 6. I'm done with the 7, I clear it. The next number in my multiplier is a 3. My right finger said so. My right finger goes to the right and waits. 3 times what? My left finger says 8. 3 times 8 is 24. Where my right finger is rating, I set the 2. I slide 1 column over and set a 4. I'm done with the 3 of the multiplier. I'm done with the 8 multiplicand. I read my problem, 296. Let's try another one. Let's tie 2 times 35 equals 70. Set 2 times 35. Now, what is the first digit of the multiplier that you're going to multiply by in 2 times 35? Hopefully you said 5. That's the first digit that your right hand comes to. I'll set the problem and let's try 2 times 35. 2 on the left-hand side, speaking over to where I set my 35, 2 times 35. I set the 3 on the fourth column, a 5 on the third column. My right hand touches the 5 as it rolls from the edge of the right-hand side over, touches the 5. 5 times what? 5 times 2. 5 times 2 is 10, or 1, 0. Where my right finger is rating, I set the 1, move over a column and set the 0. I'm done with the 5 of the multiplier, I clear it. The next digit in my multiplier is the 3. My right index finger goes to the right of it, ready to go. 3 times what? 3 times 2, because my left finger reads a 2. 3 times 2 is 0, 6. Where my right finger's waiting sets a 0, I tap it. I move to the right and I set a 6 by pinching a 5 and a 1 bead together. I clear the multiplier 3. I clear the multiplicand 2. I read the answer of 70. Okay, let's try one more. Try 9 times 56. 9 times 56. Set it on your abacus. I'm going to read the instructions, see if you can follow along and get the answer before I demonstrate it. Set the multiplier and the multiplicand. 9 times 56. Your right forefinger is on the 4. Slide it to the right. Oh, Joan, thank you. Sometimes I read numbers that aren't there. 9 times 54. Thank you. 9 times 54. We get a very different answer if it was a different number. Set 9 times 54. Slide your right forefinger on the 4 and then slide it to the right. Your left forefinger checks the 9. 4 times 9 is 36. Where your right forefinger is waiting, set the 3. Move it to the right and set the 6. Clear the 4. Your right forefinger then checks the next number in the multiplier, the 5. Slides it to the right. 5 times what? The left finger tells us 9. 5 times 9 is 45. Where your right forefinger is waiting, set the 4 of 45. Move to the next column to the right, set the 5 of 45. Clear the 5 of the multiplier and the 9 multiplicand. Let's try that one together. Set a 9 on the left-hand side. That's your multiplicand. Figure out where we set 54. 9 times 54. The 5 is in the 4th column. The 4 is in the 3rd column. Right finger reads a 4, moves to the right. 4 times what? 4 times 9. 4 times 9 is 36. Where my finger is, right finger is, I set a 3, move to the right and set a 6. Clear the 4 of the multiplier. Now what I'm multiplying by? I'm multiplying by a 5. Move my right finger to the right of that 5, ready to go. 5 times what? 5 times 9. 5 times 9 is 45. Where my finger is, set a 4. Move to the right, set a 5. I'm done with the multiplier 5. I'm done with the multiplicand 9. And I read my answer, 486. Practicing 1-digit by 2-digit numbers does not have to be complex. If you've noticed, each one of the problems that we've done so far has been done so that you do not have any complementary addition in it, meaning there's enough beads on the bar to add that part of the subproduct without having to think about any type of complementary number exchange. So take a moment and practice a 1-digit times 2-digit number. You have to know your times tables to do so. This is where, if your student is really struggling with their times tables, you could conceivably pull out that 9 by 9 times tables for them to go check their multiplication portion. That is an added barrier for them in fluency, but some students need that in order to progress in learning how to do larger multiplication problems. This still keeps the system contained. Note all of the problems in the time for practice 1-digit by 2-digit are horizontal, easy to read, easy to follow along. And once it's set on your abacus, you don't have to refer to the paper anymore. I'm going to pause here. Any questions? Okay. I added more practice for 1-digit by 2-digit. Again, all of these are problems for you to use with your student or for yourself in practicing your 1-digit by 2-digit multiplication with answers that do not have any complementary numbers in them. Let's see how you do with your next check your knowledge questions. So, true or false? In the problem, 7 times 52. The first multiplication is 7 times 2. True or false? In the problem, 16 times 5. When you multiply 5 times the 1 of 16, the resulting partial product is 0.5. The 5 of 0.5 is set in which column? Immediately to the left of the 3 of 30, containing the 3 of 30, or containing the 0 of 30. Don't worry. I know you had 2 different problems to set, so we're going to give you some time on this one. Question number 2 was confusing, Julian? Okay, we'll do that one together then. Okay, I'm going to end the poll. I'm going to share the results just so that you have the answers. It is true, if you're doing 7 times 52, the first multiplication is 7 times 2. The 52 we've placed as our multiplier with the 2. And I now realize what I wrote the problem in a backward form, Julian, so that is probably why it was so hard. 16 times 5, if I had written 5 times 16, with what we have talked about so far, would have felt more comfortable if I had said 5 times 16. So try 5 times 16 and see if that makes it answerable. I think I wrote it in reverse. And I think if you try it then, you would find that you are adding the 5 in the column that contains the 3 of 30. So thank you. You guys caught me in my own error. I just wrote it backwards for you guys. Okay. Before we start with multiple digits in a multiplier, I want to talk a little bit about multiplication with complementary numbers and start it with multiplication that you've already practiced you yourself and practiced with your students. And yes, Julian, there is a way to do it, and we are going to talk about it. Once you've practiced multiplication where the student is practicing going through the digits and not having to focus too hard on what number they're setting. They're only focusing on what number to set where, as opposed to, oh my gosh, I've got to set a 2 and I can't set a 2. Then you move on to those complementary numbers, meaning you're looking for specific multiplication problems where they have to practice that. Here is one for us to practice together. 8 times 34 equals 272. When you multiply 8 times 34, you start by setting them in their appropriate places, the 8 on the left-hand side, count over to set the 34. The right index finger on the 4, slide it to the right, you check the 8, and you say, okay, what am I multiplying times the 4? 4 times 8 is 32. Set the 3, move my finger over, set the 2, clear the 4. Then you're going to move your right forefinger to that 3. And so far, so good. Everything feels really good. When your left forefinger sees the 3 and multiplies it times the 8, it's 24. And you set a 2 and then a 4. So on the rod that your finger's sitting on, you set the 2. You move to the next rod to set the 4, and you go, oh, there aren't 4 beads for me to move. I have to add 4's complement. We have to use the 5. So we're going to set the 5 and clear the 1 bead, and then clear the answers. Let's try this one together. 8 times 34. Set a 8 on the left-hand side. Count over to set the 34. 8 times 34. On the fourth column, set the 3. On the third column, set the 4. My right finger rolls in, finds the first digit is 4, moves to the right to wait. 4 times what? 4 times 8. 4 times 8 is 32. Where my right finger is, I set the 30, move over, set the 2. Clear the 4. My right finger moves over and finds the next multiplier, 3. Moves to the right and waits. 3 times what? 3 times 8. 3 times 8 is 24. Set a 2 where my finger is. Move to the next column. I want to set a 4, but there's a 3 here. To set a 4, I'm going to have to set a 5 and remove 4's complement, which is 1. Clear the 3 of the multiplier, and clear the 8 of the multiplicand. Our answer is 272. This is where, if you haven't gone through addition and subtraction with the abacus, you are going, oh boy, that was a big exchange and that was complex. This is why you want your students to be very smooth with their complementary numbers. And when you're selecting problems for your student, you don't want to mix complementary numbers in their multiplication if what you're first focusing is on how to set and solve a multiplication problem on the abacus. I have listed a large number of what I would call simple complementary number multiplication problems so that you can practice this simple exchange. Again, if your addition and subtraction is not strong, that's where I suggest you go back. Or if you're watching your students struggle when they get to these simple complementary numbers inside of a multiplication problem, you might be able to catch which complementary numbers that they're not as smooth on and go back and just practice that subset of complementary numbers. Or you might find you yourself are not as strong with those. Let's try one of these two together. Let's try 2 times 27. It equals 54. Set the 2 on the left-hand side. Count over to set the 27. 2 times 27. Set the 2 on the fourth column. Set the 7 on the third column. Roll my right finger in to touch the 7. 7's in my working memory, and I move right next to it ready. 7 times what? My left finger says 2. 7 times 2 is 14, or 1, 4. Where my finger is, I set a 1, move to the right and set a 4. I'm done with the 7 of the multiplier. I clear it, roll my finger to the right. Now I'm multiplying everything by 2. My right finger goes to the right and waits. 2 times what? 2 times 2. 2 times 2 is 0, 4. Where my finger is gets the 0. I tap it, move to the right, and I set a 4. I can't set a 4. So I'm going to set a 5 and remove its complement, 1. Clear the 2 of the multiplier, clear the 2 of the multiplicand, read my answer, 54. Clear your abacus. Let's go down to 4 times 63. 4 times 63 is 252. Set the 4 on the left-hand side. Count over to set your 63. From the right-hand side, I say 4 times 6, 3. Where I stop my finger on the fourth rod, I set the 6. Move to the right and set the 3. Take my right finger, roll it in until I find the first digit, which is that 3. Move it to the right and wait. 3 times what? My left finger says 4. 3 times 4 is 1, 2. Where my finger is, I set a 1. Move to the right and set a 2. I'm done with the 3 of the multiplier. I clear it. What's the next thing I'm multiplying by? My right finger says 6. I move it to the right to wait. 6 times what? 6 times 4. 6 times 4 is 24. Where my finger is, gets a 2. Move to the right, I need to set a 4. I can't set a 4. I'm going to set the 5 bead and remove 4's complement of 5, which is 1. I'm done with the 6 of the multiplier. I'm done with the 4 of the multiplicand. 2, 5, 2. There's lots of problems to be able to practice these simple complementary numbers, so much so that I've given you 2 banks of simple complementary problems to practice. These are great ones to see if your students really are competent with their addition and subtraction complementary numbers. Now those were simple complementary numbers. I give you some banks of complex complementary numbers. I've just noticed that I forgot to reverse them in their order. So when you see problems like this, I promise you I will send the handout for you guys with these in the correct order. So let me go back. Well, I don't have my complementary numbers in the other order. So you guys are going to get to see them with me reversing the number. Okay, this means that the first problem we're going to do, while it says 58 times 9, you're going to exercise your knowledge of multiplication and you're going to move the 9 on the left-hand side. Okay, so set the 9 on the left-hand side. We're going to count over to set the 58. 9 times 5, 8. Set the 5 in the fourth column and the 8 in the third column. We're going to roll our finger over. We're going to multiply everything times 8. Our finger moves to the right to wait. 8 times what? 8 times 9. 8 times 9 is 72. Where my finger is, I set the 7. Move to the right and set the 2. I'm done with the 8 of the multiplier and I clear it. Now multiplying everything times 5. I move my right finger over to the right to wait. 5 times what? 5 times 9. 5 times 9 is 45. Where my finger is gets the 40. I need to move one column over and set a 5. I can't set a 5. I need to set a 10. That's pushing the 5 down and removing the 4 1 beads. I wanted to set a 5, I set a 10. I remove its complement of 5. Clear the multiplier 5. Clear the multiplicand 9 for an answer of 5, 2, 2. And clear. And I will send out a completed and reversed deck, but again, you should be able to exercise some of your math and remove move the problem around. As Joan said, the commutative property says that you can reverse it, and you can. And that's something, again, to practice with your students. They might find it easier to reverse and move the problem into the reverse column, putting the largest digit to the somewhat middle and that small digit on the left-hand edge, and that works. Carol, you asked a question about using the counting method approach instead of the complementary method. I will tell you I'm not as smooth in doing that method because the complementary number method is kind of what my brain does now. The counting method would be that one-by-one correspondence of moving up, setting like they normally do. So if they are smooth with the counting method for addition and subtraction, then they are practicing that same method when doing multiplication. They can set the problem up the same way. They're just not using the exchanges that I was demonstrating. So problem can still be set up the same way. You're just moving one bead at a time. So I have a question for you. The problem 99 times 9 is an example of multiplication with complementary numbers. Is this true or false? And I suggest you set it up with the 9 single digit on the left-hand side and 99 as we've been practicing. And then which of the following problems has multiplication with complementary numbers? Is it 49 times 8, 73 times 8, or 98 times 8? I'm giving you some time. That's a few different problems to try to solve. So Julian, which don't you know how to figure out? Either or one of them? And I think the easiest way to think of complementary numbers is if it was easy to set, it doesn't have complementary numbers. I still have people working them out. You are not, Julian. Complementary numbers are two numbers that make up, when put together, another number. So 5 plus 5, those 5s are complements to make a 10. And this is where you might find it very helpful to do the addition and subtraction course in the Hive, and then come back and watch the recording of this. You might find that really helpful. I'm going to give you guys a little bit more time. I know people are still working through the problems. I've had a few people that have said that they didn't get it on the bottom. And this is where I have realized that if I do the problem in the reverse order, sometimes you have complementary numbers, and if you do it in the other order, you don't, which is why multiplication is making questions for you guys for multiplication problems is challenging, because depending on which way you solve it, you get it. So you are correct. If you answered that you didn't find any complementary numbers in the second one, you're technically correct depending on which way you did it. So if you did 98 times 9 and then 98 was on the left-hand side and the 8 was in the middle, then you would have a complementary number. But if you reversed it and had the 8 on the left-hand side and 98 in the middle, you weren't having complementary numbers. So that is what makes it tricky. Now, the 99 times 9 has absolutely no complementary numbers in it. So that one does not have any. You can add the 81 and then the 81 without moving beads around. It works quite well. You guys are catching me on my problem. See, this is what happens with multiplication. I will tell you. Now, after going through all of those problems, at this point, the student may question the necessity of learning how to do a multiplication problem with the multiplicand of 2 or more digits and a 1-digit multiplier. Remember, that's the reverse that we were just talking about. Because, of course, they can just reverse it and say, well, I'm just going to do it the way I do best and just do it that way. They've learned it. They already know how to obtain an answer. However, you want to explain to your student that the procedure set down in this part must be learned in order to perform the advanced multiplication problems, those with more than 1 digit in both the multiplier and the multiplicand. And Julian, yes, a complementary number is kind of that regrouping. You have to use complements of numbers in order to determine what number goes on a rod. So multiplicands with 2, 3, or more digits, you're going to always multiply each digit of the multiplier, starting with the multiplier's first digit on the right, by each digit in the multiplicand in the order of occurrence from left to right. After each digit in the multiplier is multiplied by all of the digits in the multiplicand, then the digit in the multiplier is cleared with the right hand. Those are the rules, but we're going to practice this together. Sometimes it's good to hear and kind of refresh your brain about what you need to do. The first problem we're going to do is 60 times 7. This one all has to do with placement, and it's a great way to start students with a 2-digit times a 1-digit multiplier, especially with that 0. What we're going to do is we're going to set 60 on the extreme left of the abacus and set the multiplier 7 on that 4th rod, because if you said 60 times 7, the 7 would go on that 4th rod. Then you're going to move your right index finger to the 3rd rod to get ready, and the left index finger reads 7 times 6. You set 42, and you clear the well, you can try to multiply the 7 times 0 and just get 0, 0, so they can understand. But being that there's nothing there, they're probably just going to immediately erase the 7, clear the 7, and clear the 6, and have 420 as their answer, because that 4 is on that 3rd column, and then a 2, and then a 0. And that all had to do with that 7 being in the appropriate place. This is a great example for them to realize, okay, I counted over, had the right place. There just didn't happen to be anything in that second number of 60. Let's do one that has a number in that second column. We're going to do 21 times 8. 21 times 8 is 168. We're going to set the multiplicand of 21 on the extreme left. A 2 goes on the most extreme left, and the 1 goes 1 column to the right of that for 21. The multiplier 8, we would state 21 times 8. We'd land on the 4th rod, and we'd set the 8. We're going to read the problem like we're used to. The right index finger reads the 8 and then moves to the rod to the immediate right. The left index finger reads the first digit of the multiplicand, the 2. Since 8 times 2 is 16, the right finger pushes up a 1, moves to the right and pushes a 6, and then that right finger stays on the 6. You hold your finger there. I do talk to my students about holding their finger either on the bar underneath or between the 6 and the 3 beads that are below it, or on the separation bar. Try not to have your student rest their finger on the actual beads. There's an easy tendency to move them. So holding in a place that doesn't move any beads is better. With the right index finger holding that same rod, We have that 8 in our working memory. Our left index finger then moves off the 2 into the 1 and says 8 times what again? 8 times 1. We think 0, 8. Where our right index finger is waiting, we set a 0, or you tap the rod. Then move to the right and set the 8. Our left finger doesn't feel any more numbers, so we're done with the 8 of the multiplier. We go back and clear it and clear the 21 and get our answer. Let's practice this one together. We're going to do 21 times 8. Set 21 on the left-hand side. Read over to set the 8. 2, 1 times 8. Set the 8 on the fourth rod. Our right finger rolls into the 8 and then goes to the right of it. 8 times what? My left index finger goes and touches the 2, the first digit it comes to. 8 times 2 is 16. My right index finger sets a 1, moves to the right, sets a 6, holds my finger there. My left finger moves over and says 8 times what? 8 times 1. 8 times 1 is 0, 8. Where my finger is, I set a 0, move to the right and set an 8. I'm done with my multiplication. There's no more digits. So I'm going to clear my multiplier. I have no more digits in my multiplier, so I can clear my multiplicand and read my answer 168. Let's try some more simple multiplication with putting 2 digits on one side, on the left-hand side, and a single digit as your multiplier. Let's set 25 times 3. Set 25 on the left-hand side. Count over to set the 3. 2, 5 times 3. Set the 3 on the fourth bar. Right finger rolls to the 3, left finger feels the 2. The right finger is right next to the 3 on the right-hand side. 3 times 2 is what? 3 times 2 is 0, 6. Where my finger is gets a 0. Move to the right, set a 6. Leave my finger there. 3 times what? My left hand moves to the next digit, which is 5. 3 times 5. 3 times 5 is 1, 5. Where my right finger is gets a 1. Move to right, get a 5. I'm done with my multiplier. I'm done with my multiplicand. My answer is 75. Clear your abacus. Let's try another one. Let's try 34 times 8. Set 34 on the left-hand side. On the right-hand side, set the 8 by saying 34 times 8. Set the 8. It'll be on the fourth rod. Right finger moves over, reads the 8, and then goes to the right-hand side. 8 times what? 8 times 3 by reading with my left index finger. 8 times 3 is 24. Where my right index finger is, set a 2, move to the right, set a 4, leave my finger there. 8 times what? Roll my left finger in. 8 times 4. 8 times 4 is 32. Where my right finger is gets a 30. That means I have to put a 5 and remove 2. Move to the right. Set the 2 of 32. I'm done with the 8 multiplier. I'm done with the 34 multiplicand. I read my answer of 272. Do you guys want to see one more? Okay. Let's try 77 times 7. set 77. We're going to count over to set the 7 multiplier. 7 times 7, 7. Set the 7 multiplier. My right finger goes over and reads a 7. My left finger goes over, reads another 7. 7 times 7 is 49. Set the 4, move to the right, set the 9. Leave my finger there. 7 times what? My left finger rolls in and reads another 7. 7 times 7 is 49. Where my finger is gets the 40. To set a 4, I need to add a 10 and remove 6. I'm adding a super 10. I'm removing 6. Move to the column to the right and set 9. Set 9 in the ones column. I'm done with the 7 multiplier. I'm done with the 77 of the multiplicand. Answer is 139. Oh, sorry, 539. I'll do one more just for the fun of it. Let's do 85 times 2. Set 85 on the left-hand side. Count over to set the 2. 8, 5 times 2. Set the 2. Multiplying everything by the 2. Right finger's ready to go. 2 times what? 2 times 8. 2 times 8 is 1, 6. Set the 1. Move to the right. Set the 6. Leave my finger there. 2 times what? My left finger rolls in and reads a 5. 2 times 5 is 20. Where my finger is gets a 2. Move column over, set a 0. I'm done with the 2. I'm done with the 85. Well, now I wonder which problem is right or wrong. So I came up with the answer as 180. So either I did my multiplication wrong or this is wrong. One of you will tell me because I'm sure. Yeah. So if I did it wrong, and this is what I'm going to tell you because it's really important. As you are reading the problems, I said 2 times 5 is 20. Thank you. As you're reading the problems out loud, and you're going to find this happens, is you're going to state things wrong. So that does happen. And people are telling me 170 is the answer. So I might have written it wrong too. These are some of the things that you're going to find even as you instruct, is you are going to find that you are human and you do not say things even though it's the way it's written. Math is one of those processes where you voice every single movement that you make actually can slow you down and make it really hard. So you want to take some time, and I'll tell you, I practiced. You want to take the time to practice saying some of these problems and verbalizing the steps that you are taking, even writing them down so that you are ready to explain it to your students and you've actually got a script to help you. Because if you're starting to do some of this computation in your own head, it can slow you down and you can actually say the wrong words, and because we're all human. Let's look at a few more. There are more simple multiplications. Again, these are the 2-digit times the 1-digit multiplication for you to be able to practice. Let's see if you can answer these 2 problems. Let's see if these are done right with setting a problem with the multiplicand being larger than the multiplier. With the multiplicand being larger than the multiplier. So the first one says, when setting the problem 78 times 4, there will be 4 columns to the right of the 4 unused columns when setting the problem. All you've done is set it. When you've set 78 times 4. And the next problem says, if you multiply 42 times 7, which is true? The last digit of the problem will be in the units column. There will be 4 digits in the answer. The first time you multiply 7, you multiply it times the 2 of 42. Okay, I am going to end the poll. And if you answered false, you are correct. There will be three unused columns. And if you multiply 42 times 7, the answer is A. The last digit of the product will be found in the units column. And hopefully you immediately knew that B is not true. There will be 4 digits and the answer does not make sense, especially after you listen to the top one. And the first time you multiply the 7, you don't multiply it times the 2 in 42 when we are using the abacus. You would be multiplying it times the 4 first. Because we know that our students will not stay with 2-digit times 1 digit, but have to move on to 2-digit multiplicands and 2-digit multipliers, we need you to have some of that practice under your belt before you move them to this process. Note that there's this stair step through this to help you stair step your student through multiplying on the abacus. But I want to make sure we get to this, so let's try some 2-digit multiplican by 2-digit multipliers. We're going to practice 12 times 83. 12 times 83 is 996. You're going to set the 12 on the extreme left. You're going to set the multiplier 83 by counting over, and it'll end up with the 8 on the 5th rod and the 3 on the 4th rod. Note, we're moving further and further over because our problems are getting bigger and bigger. There are 2 digits and 2 digits, which means you will have to move all the way over to that 5th rod. With your right hand on the 3 of the 33, you'll read that, or 83, then you'll move to rest on the column to the right of it. 3 times what? The left hand reads the 1 of the 12, and we say 3 times 1 is 0, 3. Where your right finger is resting gets a 0, and you move to the right and you set the 3, and you hold your finger there while your left finger goes and finds out what else do we multiply the 3 by. We multiply the 3 by the 2 of the 12. 3 times 2 is 0, 6. Where your finger is, you set the 0 of the 6, kind of tap it, and then move to the right and set the 6. That 6 is going to be set on the same rod as the 3 of the 0, 3. I think I have an extra direction in there on accident. Since the 3 of the 83 has been multiplied by everything, you're going to clear that. And your right finger is going to move to the 8 of 83. You're going to kind of hold that 8 in your working memory. Move it to the right. 8 times what? Our left finger goes back to the beginning of the 12, to the 1. 8 times 1 is 0, 8. Where your right finger is, it gets a 0. Tap the rod, move to the right, and set the 8. Hold your finger there. The left forefinger moves from the 1 to the 2 and says 8 times what? 8 times 2. 8 times 2 is 16. And it's not 0, 8, it's 1, 6. So the 1 of the 16 is set where the right forefinger is waiting on the 8. Move it to the right and set the 6 of the 16. Since the 8 of the 83 has been multiplied, you clear it. You clear the 12, and you get the product 996. Let's try that one together. I do much better doing it than reading it. I'm going to set the 12, 1, 2 on the left-hand side. I'm going to set to the 83, 1, 2 times 8, 3. Set the 8 on the 5th rod, 3 on the 4th rod. Right finger rolls in and feels the 3. Left finger feels the 1. 3 times 1 is 0, 3. Where my finger is gets a 0. Move to the right, set the 3. Hold my finger there. 3 times what? Left finger moves in. 3 times 2. 3 times 2 is 0, 6. Where my right finger is waiting gets a 0. Move to the right, set the 6. I'm done with the 3 of the multiplier. Clear it. Now multiplying everything times 8. My right finger goes to the right of the 8 and waits. My left finger goes back to the beginning. 8 times what? 8 times 1. 8 times 1 is 0, 8. Where my finger is gets a 0. Move to the right and set an 8. 8 times what? My finger goes to the left and reads a 2. 8 times 2 is 1, 6. Where my finger is gets a 1. Move to the right and get a 6. I'm done with my 8 multiplier. I'm done with my 12 for an answer of 996. Now that one had no complementary numbers in it, and we know that those can occur. Again, you can make some decisions as to what you expose your students to, but let's try one complex example. The complex example is 45 times 67. 45 times 67's answer is 3015, 3015. You're going to set the 45 on the extreme left and 67 on the 5th and 4th rods. Again, you're going to move your hands over and in. In the slides, I have given you the set of directions for you to be able to walk yourself through these problems. We're going to move through these directions. Know that they are there for you if you want to read through them, but we are going to do it together. We're going to do the 45 times 67. So let's try 45 times 67. On the left-hand side, we set 45. We count over to set 67. 45 times 67. Set a 6, set a 7. They should be set on the 5th and 6th rod. 5th and 4th rod, set it backwards. 5th and 4th rod. Slide your right finger over, feel the 7. Your left finger comes over and feels a 4. 7 times 4 is 28. Set the 2 where your finger is, move to the right, set the 8. Hold your finger there. 7 times what? Move our left hand in. 5. 7 times 5 is 35. Where my right finger is waiting needs a 3. I can't do a 3. I'm going to add a 10, remove its complement 7. I did the 30, move to the right and set the 5 of 35. I'm done with the 7 and I'll clear it. Now multiplying everything times the 6. I move to the right of the 6 and wait. 6 times what? The first digit for my left hand is 4. 6 times 4 is 24. Where my finger is gets a 2. Move to the right and set a 4. I can't. I'll set a 5 and remove its complement. Leave my finger there. 6 times what? 6 times 5 is the next. 6 times 5 is 30. 3, 0. Where my finger is gets a 3. Means I need to set a 10 and remove 7. Move a column over and set the 0. I'm done with the multiplier. I'm done with the multiplicand. I read my answer 3, 0, 1, 5. Again, that's a more complex problem. Because it's a more complex problem, and we recognize our students shouldn't start with complex problems, and neither should you, I've given you some simple 2-digit by 2-digit problems to practice. Let's try a few of these together. Let's try 17 times 34. Set 17 on the left-hand side. Count over to set 34. 1, 7 times 3, 4. Set the 3 on the 5th column, the 4 on the 4th column. Roll our fingers in. So you're rolling your right finger in and your left finger in. Your right finger hits a 4. We're multiplying everything times 4. Move to the right and wait. 4 times what? Left finger says 4 times 1. 4 times 1 is 0, 4. Set a 0 by tapping it. Move to the right, set a 4. Hold my finger there. 4 times what? Left finger moves over. 4 times 7. 4 times 7 is 28. Where your finger is, set the 2. Set a 5, remove 3. Move to the right, set 8. I'm done with the 4 of the multiplier, clear it. Now multiplying everything times 3. 3 times what? 3 times 1. 3 times 1 is 0, 3. Tap by setting a 0, move to the right and set a 3. Leave my finger there. 3 times what? Move my finger over, I feel a 7. 3 times 7 is 21. Where my finger is, set a 2. Add a 5, remove 3. Move to the right and set a 1. Set a 1. Done with the multiplier, done with the multiplicand. I think it came across with a different answer again. I'm going to have to check my math on these and get these back to you. Anyone grab their quick calculator and tell me what if I was right or wrong with that one? 578. Yeah, that's what I thought. So I wrote it down wrong. The abacus is right. Yes, the abacus is always right. Isn't that true? Okay, let's try another one. Let's try 56 times. We'll do 56 times 20. It's an easy one, but we should be able to do it. Okay, set 56 on the left-hand side. Let's count over to set the 20. 5, 6 times 2, 0. Set the 2. Slide my finger over. So really, I'm multiplying everything by 2. And the abacus has helped us give that column. So 2 times what? 2 times 5. 2 times 5 is 10, 1, 0. Set a 1, set a 0. Hold your finger there. 2 times what? Slide my left finger over. 2 times 6 is 12. 1, 2. Where my finger is gets a 1. Move to the right, set a 2. Clear the 2 of the multiplier. Clear the 56. Answer is 1120. That should have felt good to all of you. Now, of course, I can't just give you simple multiplication. I've got to give you complex multiplication too. So there are complex problems with which you will immediately see have more using the complementary numbers to add beads to different rods of the abacus, sometimes skipping columns. And this is going to happen. Again, why I said you really have to focus on emphasizing that your student know their addition and subtraction clearly before they are doing multiplication. Let's try a couple complex problems. Okay. Why don't we try 98 times 98? Okay, 98 times 98. So set 98 on the left-hand side and then count over to set the other 98. 98 times 98. 9, 8. So the 9 is on the 5th rod, the 8 is on the 4th rod. We're going to roll our fingers in. All right, finger comes to an 8. 8 times what? 8 times 9. 8 times 9 is 72. Where my finger is gets a 7. Move to the right and gets a 2. Hold my finger there. 8 times what? 8 times 8. 8 times 8 is 64. Where my finger is gets a 6. Move to the right, gets a 4. I'm done with my 8. I'll go back and find that 8 and clear it. The next number I need to multiply is the 9. 9 times what? My left hand finger goes to the beginning. 9 times 9. 9 times 9 is 81. Where my finger is gets the 8. Move to the right and get a 1. Leave my finger there. 9 times what? Roll my finger over. 9 times 8. 9 times 8 is 72. Where my finger is gets a 7. I can't, so I'm going to add a 10 and remove 3 from that column. I added the 7, move to the right, and add a 2. I can't add a 2, so I'm going to add a 10, remove its complement 8. I've done the 72, so I'm done with the 9 multiplier. I'm done with the 98 multiplicand. I read my answer 9604. Complex problems. These are ones to practice after you've practiced all the other ones. These are not the ones to start with first, okay? Shall we do one more complex problem? Why don't we do 82 times 74? Okay, left-hand side gets 82. 8, 2. Right-hand side, we count over to set the 74. 8, 2 times 7, 4. Set the 7, set the 4. 7 is set on the 5th column, 4 on the 4th column. Roll our fingers in to find out what we start with. 4 on the left-hand side, multiplying everything times 4. 4 on the right-hand side. Okay, fingers ready. Left hand, 4 times what? 4 times 8. 4 times 8 is 32. Where your finger is gets the 3. Move over, gets the 2. Hold your finger there. 4 times what? Roll your left finger in. 4 times 2. 4 times 2 is 0, 8. Where your finger is gets the 0. Move to the right and set an 8. We're done with the 4 of 74. Clear it. Now we're multiplying everything times 7. Move your finger to the right and wait. 7 times what? Left hand goes to the beginning. 7 times 8. 7 times 8 is 56. Set the 5. Move over. Set the 6. Leave your finger there. 7 times what? Move your left hand over. 7 times 2. 7 times 2 is 14. 1, 4. Where your finger is, set a 1. I can't. I'm going to set a 10. Remove its complement 9. I did the 10. Move to the right, set 4. Can't set 4. Set a 5. Remove its complement 1. I'm done with the 7 of the multiplier. I'm done with the 82 of the multiplicand. Read my problem answer, or read my product. 6068. Well done. Let's let you give it a go on your own. So true or false? The problem, 57 times 25 is an example of multiplication with complementary numbers. 57 times 25. And after you've done that one, which of the following problems has multiplication without complementary numbers? In other words, which one's the easier one? 18 times 71, 18 times 21, 31 times 18. I'll give you some more time. I think people are still working through the problems. Okay, I'm going to stop. If you said true, you were correct. It was true. 57 times 25 does have complementary numbers. And the problem that did not have complementary numbers was 18 times 21, or B. I want to make sure I get through the rest of this. So just a little bit about Abacus errors with multiplication. Placement of the multiplicand, of course. You can see that if you don't have that placement correct, you're going to end up with your answer, your product, on the wrong columns, and that can be a problem. So that can be a quick and easy Abacus error. Correction would be giving them smaller problems to set, 2 times 2, just to practice that placement. Multiplying the wrong digits together. Some students have a hard time holding their hands in the places that they need to read the correct problem or read where they are. Their left finger might hop up and over and miss beads. Zeros can also be missed when they're in the middle of a problem, like 104 times 5. That 0 in 104 can be a problem. They can skip over it. They can also forget to give 0 a space when they are either setting their problem or setting their answer, just forgetting to tap the rod as if they're setting a 0 in that one place. Additionally, forgetting that subproducts only have one digit. If you were finding you were getting lots of wrong answers, and it was a problem that you're trying without me verbalizing it, it could be that you're forgetting that all answers have 2 digits. So even if the answer is 6, practicing saying 06 is really good. And starting that really early on with multiplication tables is important for your students. And then last but not least, not clearing the multiplier or multiplicand and actually reading it into your answer can be a problem. So they've left it on and they continue to read it as if it were part of the problem. So those are some of the things that you might want to watch for Abacus errors. Now, for math errors, having actual wrong numbers. Are they efficient about setting the numbers on the beads the correct way? Another math error in multiplication is they just don't know their multiplication facts, or they are really shaky on certain ones. And so that's why they're getting the problems wrong. And missing an entire multiplication step. While this is sort of Abacus problem, sort of math problem, recognizing that you should have an estimate of what your answer should be should help your student realize that they've missed an entire step of multiplying. So they should be able to estimate their answers. That's in the standards as well, that they should be able to estimate their answers. Some of the things that you can also check for wrong numbers is, are they copying the problem right? Did they read the problem right on the paper and actually transfer it to the Abacus correctly? So those are some of the things that you can practice. It could be that you want your student or yourself to kind of keep a journal of what errors are being made, kind of keep track of it as you're working through some problems with your student, and then you can build your lesson plan based on those errors that they're making during that last Abacus lesson. Math is no fun without games. So I just want to remind everyone that there are games available with numbers for your student. If you haven't lately tried Quick Pick, this is a great place to practice addition, subtraction, multiplication, and division. What a great way for them to work on their nines times tables with multiplication. It's in large print and braille on the same tool, on the same packet, so you don't have to buy something separate. This is great to pull out on the bus. Do it on the bus on the way home, or do it on the car ride on the way home. Simple, independent, easy for them to choose. It has a problem in Braille and large print, has 4 choices on the bottom. They use a Braille eraser, but you could use a pencil. It doesn't have to be a Braille eraser. It comes with a Braille eraser. You stick it in there, and then you can pull out the card. That means you got the answer right. If you can't pull it out, you got it wrong. Great way to practice. One thing to remind your student, don't do the take the card and then throw the card away. Actually, practicing the ones that you know is very good for your brain. So don't do the elimination game. Make sure that those cards are still staying in the packet. Another game that's available for free is Math Flash. This is on Amazon, Alexa, and Android. And this is a way that your student can practice their addition, subtraction, multiplication, and division. Again, great place to practice those multiplication 9x9 facts. Math Robot is on iPhone or iPad. You can set the range of numbers, operations, number of tries. There is a low vision mode as well. It has voiceover support, Braille support. It has interaction for your students to practice. Slapstack Math, again, this is another free app accessible for everyone. The goal is to collect the most points by pulling the 2 cards. You can do addition, subtraction, multiplication, division. You can do a mixture of all of them. What a great way to practice all of those facts for your students. A non-digital way to practice, you can play roll and bump. Roll and bump is a game that you'll see in lots of elementary schools. Rolling 2 die, you can make these accessible die. You can use a computer program that has dice. You add up the sums and then you multiply that number times 4 or any other digit, depending on what they're maybe struggling with. You create a sheet with just the multiplication products for that times table that you're practicing. And you can put that in large print and in Braille. And as they play with each other, the opponent, if they get the same product, they can bump it. You set a timer for 10 minutes. Whoever has covered the most products when the timer goes off, that person wins. So again, it's that practicing of your multiplication tables. While this goes much deeper, this is Animal Watch VI Suite. It's iPad. It's really your 5th to 7th grade students. It has Apple VoiceOver. It's built in to help our students solve word problems. What's great is you're actually talking about endangered species information, so you're learning a little science along the way. There's 24 units that actually align with the 6th grade Common Core standards. Again, you can kind of span it between 5th and 7th. This also covers things like multiplication, division, fractions, speed, time, distance, and converting units of measurement. So again, another tool in your back pocket to practice math. This next one, while not available through APH, there's many tools for Sudoku out there that are accessible. This one, for instance, has different markers on the top in Braille to be able to play it, but you can also add Braille to many of the versions of Sudoku that are out there. Sudoku actually improves your logical thinking, number skills, decision making, memory and recall, spatial reasoning. It's actually supposed to make one relax. Now, some of you might not like it, so then that's not relaxing. It does reduce overthinking, and it really truly is a leisure activity, so something to really think about for your student. With that, what did you take back? Well, check your knowledge. True and false. Having partial products with only one digit is a common Abacus mistake. True or false? And which of the following games offered practice in addition, subtraction, multiplication, and division? Was it Sudoku, roll and bump, or slapstack math? Okay, I'm going to stop. And if you said true, yes, partial products with only one digit is a common mistake, and you're going to find yourself doing it until you get used to that. Games that offer practice addition of subtraction, multiplication, and division. I said a few, but out of these 3 choices, only slapstack math is the one that would offer all 4 of those practices for your student. I'm going to leave you with one last thing. If your brain wants a little practice, lesson plans, I just need to share because I know that one of the things you want to think about is lesson plans for your student and how to do this. Your very, very first one would be thinking about a 4th grade student. You know that they've already done addition and subtraction. They've already mastered that. They already know their multiplication and division facts. And if you wanted to do your very, very first lesson, make sure it's an introductory lesson. It's going to do the very basic beginnings of multiplication, which could mean that you're only talking about the multiplication facts they already know through 100. Again, that's a success for your student, allows them to show their success with learning a new tool with facts they already know. And with that, I'll kind of open it up and see if there were any questions, and we can also get to a closing code.